Okay, we'll have a look at a problem involving an inclining test. An inclining test is carried out to establish a light ship displacement and kg, more importantly a light ship kg, because if your initial centre of gravity that you're using is incorrect, then all your calculations that you do regarding list or GM would be incorrect. So these inclining tests are carried out on new builds and other vessels with major changes, passenger vessels every 5 years. So in this particular problem we're given our present displacement, which of course includes all these values, our km, and we're told these weights are on board, and with a deck crane that's still ashore and has to be fitted. We're given the length of our plumb lines, which are the inclining weights are shifted 7 metres to port and starboard, and it creates a mean horizontal deflection of 0.65 of a metre. Calculate the vessel's light ship kg. A couple of things to mention here now. If it has boiler water already on board, get your ruler and put a line straight through it. That is part of the light displacement. So don't, whatever you do, put it in the table. Simply put a line through it. It's part of the light ship. Had you been told that that was still to come on board, then obviously you would add it into the table. The deck crane is still to come on board, so you must add that into the table when we draw it up. The ballast, the bunkers, the water and the inclining weights of course are not part of the light ship. So from this displacement we must subtract those values. But before we can draw up the weight kg moments table, of course we need our present kg. We're given our present km, so if we can find our present gm, we can find the kg. And when we go into our formula booklet, we can see that gm is w times s over w times length over deflection. Small w is the inclining weight, s is the length, the transverse distance we move the weight, large W of course is our displacement of 5,700, 7.85 is the length of the plumb line, and 0.65 is the deflection, and that gives us a GM of 0.83. Subtract that, it's fluid of course because we've got free surface moments, subtract that from the km and that gives us our fluid kg. So there's our present displacement and kg. Take off ballast, bunkers, water, inclining weights, not forgetting the free surface moments, because of course once you take off the bunkers and the water there won't be any free surface moments. And last but not least, we must add the deck crane because that still has to come on board. So that gives us a light ship displacement of 5033. There's our moments. Divide the light ship by the light ship moments by the displacement, and we get a light ship kg of 10.42 meters. So that will be the center of gravity of the vessel accurately calculated for its light ship condition.